Okay, well, last time we did one sample um, tests of the proportion and two independent sample proportion tests. And so now we need to do when you the case where you have more than two different categories and you are testing the proportion. And so we have a homework that's up on Blackboard, and I'm looking in the example of two questions from that. So this here, question 3 is asking, is credit worthy? So that's a variable from the data set. We're looking at a data set of um, credit worthiness loan decisions, basically, from a German bank. So they have a 1 and a 0. That's a variable that indicated whether or not the person applying for a loan ultimately qualified to receive that loan. So, and that's termed credit worthy in the database. So we've got the question is the credit worthiness of the borrower independent of stocks and bonds? So that variable in the data set relates to the dollar value of liquid securities of stocks and bonds held by the individual, and there's some categories that they fit in, under 100 marks, between 100 and 500 marks, and so on. So it's a category variable, it's not a dollar value. And then we get the question, report whether, well, we want to know, are these independent of each other? So is the size of your stock portfolio related to whether or not you were given a loan? If they are independent and they're not related, if they're independent and not related, we're going to report 0. If they're not independent, we'll report the chi-square statistic. So same kind of format as homework 1. So first I'm going to do this in SPSS. So I've got creditworthy independent of stocks and bonds. So I'm going to, here's my data set loaded up here. And so we were going to be doing a cross tabulation. So this is make our contingency table first, and then do find our chi-square value. So we want the, get lots of stuff in here. We just want two things. We want the credit worthiness to be our row variable, and then we are going to do stocks and bonds here as our column. I'll click statistics and make sure we're getting our chi-square and our Kramer's V. And I will click OK. Let me resize this so we've got some output here. So there's our stocks and bonds. So there was 5 different categories of stocks and bonds and 2 categories of credit worthy. So we can ask whether stocks and bonds, whether the proportion of credit worthy borrowers was higher for the low stock versus the high stock, or something else. So just eyeballing the proportions, right? This looks like it's about 1/5, and this looks like it's well above 1/2. And so it does look like maybe we're going to find a difference, but we'll go find out for sure. So here we've got our chi-square value of 36.099. We have 4 degrees of freedom. The degrees of freedom on a chi-square test is the degrees of freedom in the rows minus 1 times the number of columns minus 1. So we've got 5 columns, so 4, and 2 rows. So 2 minus 1 is 1. So 4 times 1, 4 degrees of freedom. So we have a chi-square statistic of 36.099. And that, looking at this p-value, is below 0.05. So we reject that these two groupings are independent. So there is a difference. The number 1 category for stock and bonds are much less likely to be approved for a loan than the number 5 group. And that would mean 36.099 would be my answer that I type into my question 3. So that is running a chi-square test in SPSS, which is what we saw last time. So I want to do now the same test using Excel. So I'm going to go, here's our data set, and I will be here. Let's make this the right size. I'm going to insert in here, we want a pivot table. And we want to make sure we get the whole thing. So we got all the data. So we've got all the data, and we're going to do it in a new worksheet. So we've got the data selected, new worksheet, and hit OK. You get this dialog box with lots of choices. So we want credit worthiness to be in the row. That's how we had it in SPSS. And then we had stocks and bonds. There they are, stocks and bonds in the column. then for values, it's